Okay, so we have this integral, and what we can do is just separate the numerator over its denominator. So we're going to have e to the 3x over 3 e to the 2x. And when we're dividing, we subtract the exponents. So 3x minus 2x is just x, 1x. So we're going to have e to the x over 3. And I'll put the 1/3 outside. I'll just separate these. So now I can put the 2/3 outside from this one. And that's going to be e to the x over e to the 2x. So x minus 2x is negative x. So we're going to have 1 over e to the x. Or I guess I should just write e to the negative x dx. And then we're going to have 4/3. And then that's going to be e to the negative 2x. Okay, so then this is just going to be e to the x. This is just going to be 2/3 e to the negative x divided by negative 1. So I'll just do a negative out here. And then plus 4/3 e to the negative 2x divided by negative 2 plus c. So yeah, we'll have 1/3 e to the x minus 2/3, and I'll put e to the x on the denominator, and then minus 2/3, and then e to the 2x on the denominator plus c. So that's I. Double I, same thing. We can separate the numerator over its denominator. So we're going to have 4 to the x, which is 2 times 2 to the x over 2 to the x. And, or actually, I can just write that. You could do it that way, it's fine. But then we should just do 4 over 2 to the x. That's fine as well. And then we're going to have 2 over 2 to the x. And then we're going to have 1 over 2 to the x. So this is 2 to the x. This is just 1. And this, I'll just write 2 to the negative x dx. Okay? All right, so we have the 2 to the x. That's just going to be 1 over natural log 2 times 2 to the x. Then 1 becomes x, and then this is going to be, because we would just do 2 to the x and then divide by negative 1. So I'm just going to make a negative on the outside. And then that's going to be 1 over natural log 2. And then it's 2 to the negative x. And then plus c. Okay, so use appropriate trig identities. So for tangent squared, I would usually say get the squared away. But we actually have the integral for some of the squared stuff. So we have an integral for secant squared, and we know that 1 plus tangent squared is secant squared. So tangent squared is secant squared minus 1. And like I said, the integral of secant squared is tangent, and then minus x plus c. And then pretty much the same for cotangent squared. We have 1 plus cotangent squared is cosecant squared. And we have the integral of negative cosecant squared is cotangent squared. And these are in the standard derivative section, so it's going back from the derivative to the original function. So they're not actually in the standard integral part, but just look in the standard derivatives. So, yeah, we have, this is cosecant squared minus 1. And cosecant squared is going to be negative cotangent squared. Negative cotangent. And then minus x for the minus 1 plus c. All right, these ones you have to be able to recognize. The previous ones where we had x up top was different, but here we just have the 3 up top. So really we could write this as 3, 1 over x squared plus 3 squared dx. And this is going to be, if you look in the 5.15 standard integrals part, this is going to be the arctan. So we have that a is 3. So we're going to have 3 and then times 1 over a, which is 3 arctan. And then x is just x over 3 plus c. All right, same with the next one. This is going to be 1 over, I'm going to write it 1 squared because that's how it is in the formula booklet, 3x squared dx. So the 3 from the outside the integral times 1 over a, which is 1, arctan, and then we're going to have 3x over 1, and because it's not just x there, it's 3, we actually have to divide by 3. So I'll put that here, plus c. So really it's just, because this all cancels, it's just arctan 3x plus c. Okay, this one, we can take the 3 out, and this is going to be the arc sine. Okay, so this is 3 squared minus x squared dx. So this is going to be 3, and then we have arc sine. X is just x. A is 3 plus c. And then for this one, double I, we'll have 1 over square root 1 minus 3x squared dx. So we're going to have the 3 from the outside, arc sine, 3x over 1, and then dividing by the 3 because it's not just x in there, it's 3x, so we have to divide by the derivative, plus c. So it should be just arc sine 3x plus c. Okay, this one is also going to be a tangent, so arctangent. So we have the 7, and then I'm going to write 2 squared plus x minus 1 squared dx. So we've got the 7 on the outside, and then we have times 1 over a, which is 2, arctan, and then x minus 1 over 2, and there's no reverse chain rule, plus c. All right, so this one, 7 out, 1 over, and this is 2x minus 1 squared plus 1 squared. So 7 from the outside times 1 over 1, because a is 1, arctan, and then it's 2x minus 1 over a, which is 1. We also have to divide by 2 here because reverse chain rule, plus c. So 7 halves arctan 2x minus 1 plus c. All right, this is going to be an arc sine, 7 out, 2 squared minus x minus 1 squared dx. So 7, and then we have arc sine x minus 1 over 2 plus c. And for double I, we're going to have 1 squared minus 2x minus 1 squared dx. So 7 arc sine 2x minus 1 over 1, divide by 2, reverse chain rule, plus c. All right, B, C are real numbers. Find the integrals. So I guess A is also a constant. So we have like this. I suppose. So we are going to have, this is arctan. So we're going to have the A from the outside, and then 1 over root C, because that's our A from the formula. Arctan, and then it's square root of B x over root C, and we have to divide by square root of B because of reverse chain rule, plus C. For this one, this is going to be arc sine. So we have like that. So we're going to have A arc sine square root of bx over square root of c, and we have to divide by square root of b plus c. Okay, so we want to show this. This is fine. We can go from the right side to the left side. But this is partial fractions to write that left side as the right side. And in your syllabus, there's only a maximum of 2 distinct linear terms. So you should have, like, it would be fine if it was x times x plus 2, but since there's a squared one, that's not distinct. So yeah, we will go from the right-hand side and show it equals the left-hand side. So we have to make the same denominator. So this one needs an x, this one needs an x plus 2 and an x, and this one needs an x plus 2 squared. So we will have 3, expanding this out, x squared plus 4x plus 4 minus 2x squared minus 4x. Don't forget, this is like plus a negative, so that negative needs to stay with that 2. Then minus 5x over our x times x plus 2 squared. And then that's going to be 3x squared minus 2x squared, so x squared. 12x minus 9x over here, which is 3x, and plus 12 over that. So this is the left-hand side. All right, so that's A. B, hence find this. So we know that thing is equal to 3 over x. So yeah, I'm going to separate all of them. So it's going to be 3 and then 1 over x dx minus 2, and that's going to be 1 over x plus 2 dx, and then minus 5, and then that's going to be x plus 2 to the negative 2 dx. So we are going to have 3 natural log x minus 2 natural log x plus 2 minus 5 x plus 2 add 1, divide by that thing. So we can rewrite this as just plus outside, and this as over x plus 2, and then plus c. Okay, so this one's going to be a partial fraction. So we need, okay, so first we can do like this. This is going to be x plus 4, x plus 2 dx. So we down here need to figure out, this is going to be equal to, I can put 0, x plus 1 because of 1 and no x's. So, and that's going to be x plus 4 times x plus 2. You can totally do the cover-up method here, which I'll review, but sometimes they make you show it, so we should practice that as well. X plus 4 top and bottom. So separate them, make the same denominator, so you're going to have ax plus 2a plus bx plus 4b over x plus 4, x plus 2, and this needs to be equal to 0x plus 1 over x plus 4, x plus 2. And we will have the a plus bx is 0x, so we know a plus b equals 0, and we know 2a plus 4b is 1. So we can say that a is negative b, so this is going to be 2 times negative b plus 4b is 1, so negative 2b plus 4b is 2b. So b is 1/2, so that means a is negative 1/2. So this up here is going to be 6 integral of negative 1/2 over x plus 4, just putting them back into this thing, plus b, which is 1/2 over x plus 2 dx. So I can actually factor out a negative 1/2 outside the integral. So that's going to be 6 times 1/2, which is 3 integral. And now we're going to have, I'm going to put this one first. So we're going to have 1 over x plus 2 minus 1 over x plus 4 dx. So finally, we're going to have 3 natural log x plus 2 minus natural log x plus 4, and then plus c. And that we can combine the natural logs with division. And that's that. Okay, so just real quick, the cover-up method. If we have a over x plus 4 plus b over x plus 2. So for this one, we have x equals negative 4. And for this one, we have x equals negative 2 when we set those to 0, right? And this is equal to 1 over x plus 4 times x plus 2. Okay, so when we use this one, okay, we cover it up, okay? So, yeah, so we cover that up, and we substitute x equals negative 4 into the remaining stuff. So it's going to be 1 over negative 4 plus 2, which is negative 2. All right? That is going to be a. All right? So if we now use the negative 2, we're going to cover up that one. And we substitute it in here. So we're going to have 1 over negative 2 plus 4, which is 2. And that's going to be the top of that thing that we covered up. Okay? Just to remind you. So we get the same thing up here.